So now we look at Ohm's Law. You've heard about Ohm's Law before, and it's a simple linear equation, but it's powerful. There's applications everywhere. So it's the idea that the voltage, a lot of times we consider the voltage drop calculations using this. The voltage for a circuit or segment of a circuit is the current running through that segment or device even multiplied by the resistance of that device. So if you had a single resistor, for instance, let's see, battery, a single device, you'd have the voltage and you'd have a current running through the device, and you'd have a resistance for the system related to that device, and maybe an internal resistance for a battery, resistance of the wires, all basically added up to that one resistance and the device. We consider that a system resistance. So you'd have everything you would need to find some unknown. For instance, let's say you wanted to know what current would be running through here so that you'd know what circuit breaker you'd needed. Let's say that this was an AC circuit. You'd need a certain amperage breaker or fuse even for these. So we have Ohm's law, sometimes in triangular form. And then we remember the power equation, again, sometimes in triangular form, just because we like those with our little linear equations. We can substitute the Ohm's law equations into the power equation, the pi equation. And we can get a couple other useful equations. The whole reason for reorganizing these is if we don't have certain values. So let's say that we didn't have the voltage, but we wanted to find power. So voltage is current times resistance. Well, that's Ohm's law. That's the basics. I don't even need to rewrite that, right? So if voltage is current times resistance, we can actually plug that in, and we'd find that power is current times current, which is squared, times the resistance. So we could actually find power without knowing voltage if we knew resistance and current flow. Now let's say that we wanted to substitute in the current. Well, we know that current is voltage over resistance. So power, substituting in, is voltage times voltage, or voltage squared, over resistance. So we actually have two really useful equations here for power. So in this second case, if you didn't know current, but you knew voltage or voltage drop over a resistor, you could find the power rating for that. That's very useful if you're asked how much energy per second, or basically how much power is present or rated for a certain device, given the proper circumstances. Now, this question of Kirchhoff's laws, I'm going to present to you in a slightly different fashion.